All right, so video A focused on just kind of taking those expressions and reducing them down. We're gonna add in one additional step in video B, and we're gonna be multiplying and dividing one rational expression times another. So multiplying, what we do there is we multiply the numerators and multiply the denominators. Okay, it's very similar to multiplying fractions out. Okay, so we're gonna multiply the numerators together and multiply the denominators together. Okay, and when you're reducing, you can choose to reduce first or you can choose to reduce second. I'll kind of explain what I mean when we're looking at examples. Dividing is really similar to multiplication, but to divide, you're multiplying by the reciprocal. Okay, so dividing is equal to multiplying by the reciprocal of the divisor. And then it becomes just like a multiplication problem. All right, so those are some little clues to get you started here. So let's look at this one. So like I said, you can either multiply everything together first, or you can reduce down as much as you possibly could to begin with. So I will show you kind of one of each. So this one, let's say that we multiply everything together as kind of a first step. All right, so what we're gonna do is we're gonna have 8 times 7, and then times x, and then times y squared. All of that over. And then this, I'm gonna have 21 times y cubed times 16 times x cubed. So I'm gonna do this one just about as you know, drawn out as we possibly can. The more you practice these, the easier they'll become. But what I'm gonna do here is I'm gonna take the numerator and denominator, break them down into all of their possible factors. Okay, so 8. If I break 8 down into prime numbers, it becomes 2 times 2 times 2. 7 is already a prime number, so I can just leave it. I have a single copy of x, and then this is 2 copies of y. Okay, so that is every single prime factor that I have in the numerator. And then I'm gonna do the same thing in the denominator. So 21, I can break that down to 3 times 7, and those are primes, so I can stop there. And then I have 3 copies of y. 16, remember, is 4 copies of 2. Like I can break it down to 4 and 4, and then each of those can be broken down. And then 3 copies of x. So I should extend this a little bit. All right, so what we're gonna do is look for anything that the numerator has, the denominator also has, then they would cancel each other out. So I have 2's, 3 copies that'll cancel out like that. I have 7's, this x, and then I have 2 copies of y. Okay, so if we look at the numerator, absolutely everything canceled from the numerator, so what that means is I technically am gonna have a 1 left behind. Don't forget about that, because the leftovers are all in the denominator, so make sure that you're not just forgetting about the numerator. So I will have 1 over, and then it's kind of hard to see, so here's what I've got left. Okay, so I have 3 times 2, so I'm gonna have a 6 in the denominator, and then I have 2 copies of x and 1 copy of y. So that would be the final reduced answer. Canceled out everything that was common, multiplied these together, and just simplified it down. All right, so B, this is division. Okay, so make sure you're paying very close attention to whether you've got division or multiplication. So when we say multiply by the reciprocal of the divisor, that means this guy stays exactly the same. The first one, I'm not changing anything. But then I'm going to multiply by the reciprocal of this one, so I'm flipping. So the denominator becomes the numerator, and the numerator becomes the denominator. Okay, so I told you with this one, we would try to cross-reduce as kind of a first step. So this one, I'm going to look at some of the numbers that I have. So I have 10 and 5. So as long as I have something in the numerator and something in the denominator, I can reduce it down. So 10 and 5 have a common copy of 5. I'll be left with 2 here, and this will just cancel. 6 and 3, I have a common copy of 3. So divide by 3, this leaves me with 2, and this would just cancel. M's, I have 1 copy here and 5 copies here, so this one will cancel. Here I'll be left with 4 copies still. The C squareds, notice those will completely cancel. I have a common copy of D, so this will cancel. This will leave me with just 1. And nothing else will cancel with those K's. Okay, so Now, so notice this one I said I would multiply first, then cancel. This one I said I was going to cancel first and then multiply. So that's what I'm doing here. So now I can multiply everything together. So I've got 2 times 2 is 4. And then I have a k squared and a d. Those are the only things that I was left with. And then in the denominator, this all canceled. This is just an m to the 4th. Okay, so that would be my final answer for that one. Okay, so that's multiplication and division. These are called monomials, just one term and one term. These are polynomials, so I've got expressions that have addition and subtraction in the middle. If you're dealing with polynomials, you're probably going to have to factor before you start either multiplying or dividing, so that's what I'm going to do here. So k minus 3, there's nothing I can do to factor that, so I'm just going to leave it. Same thing with the k plus 1. There's nothing I can do to factor that. This numerator is the difference of squares. All right, so notice it's in the opposite order of the way I'm used to seeing it, so I'm actually going to take out a negative and then flip the order. That'll be something we're more familiar with. This should be an equal sign. Sorry, that's multiplication. I have a negative, and then this k squared minus 1, I can factor that to k plus 1, k minus 1. And then in the denominator here, this can factor down. So I'll start with k and k. That'll get me my k squared. And then to multiply to positive 3 and add to negative 4, I would have a negative 3 and a negative 1. Okay, so let's look for what I can cancel. So I have these k minus 1s will cancel, one in the numerator, one in the denominator. These k plus 1s will cancel, and these k minus 3s will cancel. As long as I have one copy in the numerator and one in the denominator, they can cancel. It doesn't matter if they're directly on top of each other or if it's like this numerator compared to this denominator, because they're all going to get combined together anyway. So all I have left is this negative sign. So my final answer is just a negative 1 once that all reduces down. Okay, so we've got multiplication of polynomials. We're going to look at one more. This is now division of polynomials. So same thing, we are going to factor everything down as much as we can first. This looks like it doesn't factor, but it actually does have a copy of 2 that you can factor out. And then when I divide both those terms by 2, I would have d plus 3. In the denominator, I start with d times d. And then I want to multiply to negative 2 and add to positive 1. So that would be plus 2 minus 1. Now this is division. So again, make sure you're very, very careful when you see division. You've got to flip and multiply. So times, now this is going to be my numerator. So I can factor that down. This is going to be, again, d times d. We'll give you the d squared. This time we want to multiply to 2 but add to 3. So these would both be positive this time, plus 2 plus 1. And then this d plus 3 got flipped to the denominator. Okay, so now that everything's factored as much as we possibly can, we are going to do some canceling. So we have a d plus 3 that can cancel, a d plus 2 that can cancel. These ones super close, but not close enough, so there's nothing we can do with those. So I can either distribute that 2 or just leave it on the outside. It doesn't matter. Totally your call there. And again, one thing I will continue to remind you, you cannot cancel these d's. The term has to be identical in order to be able to cancel something like that out. Okay? Last thing we're looking at is complex fractions. You'll see this looks crazy. We call it a complex fraction because it's a fraction of fractions. The numerator is a fraction and the denominator is a fraction. What we can do here, we've technically got this numerator divided by this denominator, and if you remember from up here, division means you flip and multiply by the reciprocal. So we're going to take this numerator and then multiply by the reciprocal of this. So I'm flipping this currently. Okay, so it just turned it into a multiplication problem rather than a division problem, just like we did up here. All right, so now x squared, there's nothing I can do to factor that down. This denominator is technically the difference of squares. This is a perfect square, so is this. So this I can reduce, this would be 3x times 3x would give me that 9x squared. And then for the 4y squared, I would have 1 minus 2y and 1 plus 2y. Okay, now times this one. Okay, so let's reduce everything we can, starting with these x's. I have 2 copies here. 2 of these cancel, leaving me with just 1. And then these 2, notice they're almost identical. I've seen this enough to recognize that it's going to cancel and leave me with a negative 1 behind. Because this is a positive 3x, this is a negative 3x, negative 2y, positive 2y. They'll cancel, but they will leave me with a negative 1 behind. I've seen that pattern a bunch now. So my numerator is now just a -1. In my denominator, I have an x, and then I also have this 3x plus 2y. So again, you can either multiply that x in or just leave it.